Welcome to 28th lecture. We were discussing about the double layer 3-phase balanced winding, how it is wound. It is necessary to know these basics, then only we will be moving rather at a increased pace through the course, if these basics are clear. And it is also very interesting to know how the windings are laid in 3-phase machines, AC machines. So, last time the problem I was discussing was I want to make a double layer winding, but this time each coil will be short corded by say 1 slot. This angle is given and the specification is total number of slots 24, number of poles 4 and electrical angle between the two consecutive slot is beta is equal to 30 degree and if it is a full pitched coil then obviously 6 slots will be the coil span or 180 degree electrical, but I have been told to make a winding which is short pitched by 1 slot, that is by 30 degree, which is that means epsilon is 30 degree and a coil span is 5 slots. Now, for the R phase I completed this. So, what is the thing? Once again 60 degree phase spread winding I am want to do 60 degree phase spread. What does that mean? That 180 degree of space will be equally shared by R phase, Y phase and B phase coil sides. Therefore, if it is 60 degree, then each under 180 degree span, two slots will be shared by R, 2 will be shared by Y, 2 will be shared by B. So, I start with the R. So, first 2 slots 1 to 6 dashed and then 2 to 7 dashed, and this is suppose under south pole and corresponding representation in terms of coil. It makes sense to represent it like this, because between 1 and 6 dashed I mean that there is a coil with true terminal 1 and 6 dashed. So, 2 7 dashed. Then for R phase the next group of coil, this is one group mind you, group 1 of R phase. Similarly, this will be group 2, but where will be the next 2 consecutive slots allotted to R phase? It will be 180 degree after that, because after all south pole will finish after 180 degree. So, it will be then 1 plus 6 7 and 8 should be allotted, then 7 and 12 dashed is its return, it will be like this, so on, and this is group 3 and this is group 4 and this is how we got. And polarity of the voltages we know, if we assign start of a coil to be positive under south pole, then 1 2 will be under south pole plus plus minus like that. But this time the start of the same R phase second group coil will be 7 minus plus for obvious reason, because direction of rotation is same, only polarity of the poles has reversed. So, like that we have decided this. Then we will of course connect them in series to get the group terminals. Okay. Group terminals are available. Now, for Y phase, short cording a coil by 1 slot does not change all the things, other things remain same, that is Y phase should start after 120 degree apart. So, that slot number is 4. So, start of Y phase must be this to this 5, how do I get 1 plus 4? So, because 4 slots corresponds to 120 degree electrical and so on. Similarly, 5 10 dashed 6 11 dashed, and once you get this one, this is group 1 of Y phase. Similarly, group 2 of this thing will be, this will be 11, 5 plus 6 11 and 11 plus 5 16 dashed, then 12 17 dashed, and here it will be 13 plus 4, that is 17, and then plus 5 22 dashed, and 18 23 dashed. So, altogether for there are 24 coils. So, 8 coils should be there. So, 1 2 3, another 2 will come, and this will be 14 here, 14 plus 4 18, is it? No. Oh, 19, this is 19, 19 plus 4 23, is not, and 23 to 5, that is 25 dashed means 1 dashed, and then 24 23 plus 5 28. So, 4 dashed, and this will be 5 dashed, is that clear. So, there are altogether. So, this is group 1, group 2, group 3, group 4, but and the coil representation will be like this. I will not complete this, because you have understood and you can do the rest of the things. So, then polarity of the assigned polarity should be assigned to the induced voltages, like this. Under south pole, if it is plus, this will be reverse, this will be plus minus, and this is minus plus and minus plus. Then you have to connect all these things in series, so that they will be all additive voltages, just in the same fashion of this. So, I am not repeating that. In this way, you can see you can still complete a balanced 3 phase winding voltage, but this time it is one slot, coil span is reduced by 1 slot or 30 degree. So, we can do that. Okay. So, it can be extended to any number of poles. I hope you will be able to do for 6 pole machine 36 slots, and even if it is short corded by a given number of slots, I will be, if it were short corded by 2 slots, then coil span would have been 4 here in this case. But you will soon see that everything is nice, all these slots will be filled up nicely and windings can be completed. But by how many slots it should be short corded is to be decided, depending upon which harmonic voltage you want to reduce. So, this is the thing. Achha, now, and I am not doing translating this to this winding, you will be in a better position to do that. Now, today I will just the last of these windings that I will tell is there is another winding that is called 120 degree phase spread winding. It is sometimes used 120 degree phase spread winding. See, the what is the other thing we have studied? 60 degree phase spread winding. Generally, this phase spread angle is denoted by this letter sigma. Okay, sigma equal to 120 degree. Here it was sigma equal to 60 degree, and this we have done. We have seen this. this 60-degree phase winding. In fact, we have been doing all the time 60-degree phase winding. What does it means? That 180-degree space or one pole, this slot should be equally shared by R, Y and B phase. That is what we have done. Now, the question is, what is then phase spread sigma 120 degree? It says that okay, instead of 180 degree over which you equally divide R, Y and B phase, you take 360 degree electrical, take 360 degree space, that is about 2 poles, take 360 degree and divide equally among the phases. Okay, divide equally among the phases. So, windings are distributed. In this case, winding is distributed 60 degree for a particular phase. In this case, windings I mean spread over 120 degree for each of the phase. For example, let us take S equal to 12, P is equal to 2, and I ask you do a full pitched winding, because I know how to tackle short pitched. So, take full pitched winding, but the winding should be sigma equal to 120 degree. That is the thing, and double layer it is, always double layer. These are the inputs given to me, and I have to make a winding table for this one. So, there are 2 poles. So, over 2 poles there are 12 slots. Therefore, under this 2 pole total number of slots should be equally divided. Okay. Therefore, what is that? So, slots, and this gives you the value of m, okay, that m sin beta by 2 by m sin beta by 2 in the distribution factor while calculating. So, m it is slots per pole pair it is, okay, pole pair. So, in this case it will be 12 only. Slots per pole pair is 12 by 1, that is 12. Okay. And then out of this 12, so slots, and that is 360 degree. So, slots to be allotted to each phase will be this 12 divided by 3, 4, and this will be the value of m per phase. So, 12 slots are there over 12 poles, per pole it will be, this is the value of m. So, what we will do is this, very simple, otherwise it is 2 pole structure. So, I can complete that winding table in this space. So, suppose R phase, okay, and you start for R phase with slot number 1, and incidentally we have calculated slots per pole is 6 and beta is equal to 180 by 6, 30 degree. Separation between two consecutive slots is 30 degree. Therefore, coil span is also 6. So, 1 7 dashed will be the first coil, then 2 8 dashed, but then do not stop 4. Earlier we were doing 60 degree phase spread. So, 3 9 dashed and 4 10 dashed. How many total coils are there? 12. So, for each phase there will be 4 coils, that is that's it. So, in that is the group is now 4 in one stroke, nothing like here you give a gap, then put 3 in the under south pole, not like that. You go on placing this, because you have been allotted 4 slots for immediate group connection. This is for group connections, group formation. It will be clearer. So, this is R phase. Then what should be Y phase? Y phase should be then 1 plus 4 5 and 11 dashed, and then continue 6 12 dashed. If any mistake, point out, 6 12 dashed, 7 13 dashed is 1 dashed, and 8 2 dashed, and Y phase is over. And then B phase 5 plus 4 after 120 degree B phase starts. So, 9 plus 6 15 dashed, that means 3 dashed, 10 4 dashed, 11 5 dashed, and 12 6 dashed. So, this will be these windings, and in this case, is it just looking at it, can you tell it is 12 slots, na? So, what I am telling is, in this case we do like this, at least one I show, so that you can understand. This is the thing, and this is suppose these slots. So, I name these slots 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, what it is telling is, to complete the R phase winding 1 7 dashed. So, R phase, let us use red color only. So, 1 and 7 dashed. So, 7 dashed is here. It is 2 pole machine, that is why diametrically opposite. Then 2 8 dashed, 2 8 dashed, 3 2 8 dashed, any mistake? Oh, sorry, 3 9 dashed, is not 3 9 dashed, and 4 10 dashed. So, this is 8 dashed, and you see all the 4 coils for R phase has been done. As I told you, I will not do for Y phase and B phase. they will be exactly same, but the start will be for y phase from slot number 5 with different color I can reproduce this. But the point to be noted is here I have distributed the coils in 4 consecutive slots, not 2, then went to under south pole, not like that. So, 2 poles are there, under 2 poles all the coils has been distributed, and if they carry current, suppose these are carrying cross current, through the one current I am allowing to enter. Therefore, these will be all cross, 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 others will be dot, dot, dot and dot, and as expected 2 poles will be produced like this here, lines of forces will be like this. So, that this side will become north pole of this iron, half and half south pole. In the exactly same fashion, if I wish I can put other conductors for y and b phase, each one of them has to produce 2 poles and they will produce it. So, this is the thing. Then the question is, I will this must be pointed out that in this case, see this is one 2 poles here, 2 poles. Okay. Therefore, these coils if you take, four coils are there for this, and the induced voltages if you sketch, you say okay, this voltage 1 7 dashed, 1 7 dashed I am not writing, it should be reproduced here, it will become too clumsy. So, plus minus, plus minus, plus minus, plus minus. This way I have to write the voltage, indicating that this potential 1 and potential 2, 2 will lag this by angle beta, this will lag by beta, this will lag by beta. So, the polarity of the voltage of this coil side with respect to that will be like this. Therefore, while forming this is one group, that is all. So, it will be all four are to be connected in series like this, and these two will be your R phase terminal R 1 and R 2. Similarly, for Y phase and B phase it can be done. So, in 60° phase spread winding, per phase voltage will be like this. If this is the first coil voltage, second voltage will be lagging it by beta, then this voltage will be lagging it by beta, and the fourth coil voltage will be lagging by same angle beta, and this will be the resultant voltage, say E R 1 R 2. This information's values I am not writing, it is understood, E 1 7 dashed, E 2 8 dashed and so on. So, this will be the R phase voltage. Now, see in earlier case for 60° phase spread, we had group voltages like this, 2 groups. For 2 groups it was like this and so on. This is how, therefore, here distribution is more, distribution of the coils of a particular group is more, and K d, to calculate K d, the value of m which should be taken is now 4. That is what I wrote. This m, you must not misunderstand me in this way. Slots to be allotted to each phase globally, if you see total number of slots, whether it is 120°, whether it is 60° phase spread, it looks like 1/3 of the total slots must belong to R phase, 1/3 of y phase must belong to y phase, like that it will be there, but that is not the issue. Issue is that in immediate succession of a coil, there will be 4 numbers instead of 2, which we used 60 degree. Of course, 2 is not a unique number, depending upon number of slots, number of poles, that number itself may vary, but with respect to the examples we are considering, this is how it should be looked at, and your distribution factor in this case will be less. That is why 120 degree phase spread is not that popular. In other words, what I am telling is this sigma, if you look at it, is nothing but m into beta. How many coils you have distributed in a group, that number into beta is the number of angles occupied by a particular phase. This is also m beta. Is not? It has to be like this. Therefore, this is how this 120 degree phase spread winding can be wound. You will get a successful 3 phase balanced winding, and you can do some examples, but the point I want to say that K d is equal to sin m beta by 2 divided by m sin beta by 2. This m value is not that number of slots per pole per phase. That is true if it is 60 degree phase spread winding. That number will change if it is a 120 degree phase spread winding. You should be very careful while solving problems. 120 degree phase spread winding, m is not equal to number of slots per pole per phase. It is rather number of slots per phase per pole pair. That is the difference. Anyway, but this K d value will be lower compared to a 60 degree phase spread winding, because we were only spreading 2 coils. So, voltage loss is less here. Anyway, this is 120 degree phase spread winding. Only thing to give a complete treatment to this, I will try to see what happens if it is a 4 pole winding. Okay. Suppose the same 12 slots, I say that S equal to 12, S equal to 12, or S equal to 24 is, suppose S equal to 2, 12, in 12 nothing to show. Okay, we will continue next time this thing.